This final project is entitled Do a Barrel Roll, inspired from, of course, Star Fox. But we are actually going to be doing an axial roll by an autopilot. This is my system. You can see here I've got my joystick controller, which then goes into my RCAM system, which then visualizes. I have in the loop here an autopilot with a switch. The trigger for my joystick will flip my switch from being manual control into autopilot control. With the trigger engaged, it is manual. With the trigger released, it is autopilot. So, into the trigger, I have the joystick input from Simulink, and then I'm selecting the axes. I am inverting them, and then to balance the throttles to go to 0 to 1 instead of -1 to 1, I am adding a -1 or subtracting a -1 and gaining it by half. And then this is just a terminator of all the other buttons except for the trigger. The switch, like I said before, activates manual controls when the trigger is depressed and switches to autopilot when the trigger is released. I have scopes for my controls and for my states. The RCAM system is just a normal RCAM system with the navigations position north, east, and down added in. So it runs my old RCAM model and then uses a rotation matrix to get to position north, east, down. For the visualization, I grab the last three states, the position north, east, down, and put it into my geodetic block. The geodetic block takes those position north, east, down and puts them into the flat earth to LLA Simulink block with a height reference of -2000, so that way we are flying in the air instead of underneath the sea. It then goes into the visualization block that was given to us. Lastly is the autopilot. The autopilot has 4 PID controllers. U, V, and W go into compute the velocity. The velocity is set to 85 and uses a PID controller which has low proportional integral. From this PID controller, it then goes into saturation of 0 to 1 because the throttle can only go from 0 to 1. And that's controlling both throttles simultaneously. P, Q, and R are being terminated, as are position north, east, and down. Phi is going into a PID controller where it is set to a constant of 2 pi, so it'll roll to 2 pi. The PID controller has a pretty high proportional gain and 0 integral, 0 derivative. Both the integral and derivative were causing the system to become unstable, so it's basically just a P controller. Gains are inverse on all the controls. It is saturated, so it can only go from -1 to 1. Next is theta, which is at a constant of 0.1, so it has a slightly upward pitch. It is just a proportional controller where the proportional gain is external. The proportional gain is from a MATLAB function where I'm taking in phi, and then if phi is between pi by 4 and 6 pi by 4, so basically if it's inverted, the proportional gain is very low because I found at this inverted state the PID controller controlling the tail elevator was throwing everything off and making it uncontrollable. And then I switch it back to 1 so that way it'll level out once it's outside its inverted state. The elevator is saturated to go from -1 to 1. Next I have psi, which is set to 0. It's just another very low proportional controller just to give us a little bit of extra control on the rudder saturated from -1 to 1. So with this, I can fly manually holding the trigger, I can release the trigger and autopilot will take over, and then it will level out once it's reached 2 pi. Let's take a look at that. We are starting the controller and I have control. The trigger is depressed. You can see that I'm flying the plane. I then let go of the controls, it performs an axial roll, and now it will level out. I can then regain the controls by pulling the trigger and letting go and it'll level out.